Hi everyone, Mrs. Basega here, and today we're working on this resistance equation. Resistance is equal to rho, that's the resistivity of a specific material like silver or gold, times the length of that wire. If you imagine a wire like a cylinder, its length would be measured in meters, divided by the cross-sectional area of this wire. All right, so let's do some examples. First off, a level 1 problem. Let's do proportions. With this equation, let's say that I double the length and triple the area of some wire. Doubling the length would make it have more room that the electrons need to move through. It's like running a longer race. So doubling the length would double the resistance. Tripling the area would give more space for the electrons to move. They wouldn't bump into each other as much because they can spread out over this larger area, we can imagine. So that would make it 3 times easier to move. With proportions, all in all, our new resistance is 2/3 of what it was originally. 2/3, because this number is less than 1, means that it is 2/3 less than before. If this was a larger number than 1, it would mean it was more resistant than the original wire. Now let's step it up a notch. Let's say I know the original wire has a resistance of 10. Let's say the resistivity of the material is twice as big. And let's say the length is 3 times as long. Making those changes would increase the resistance. Having more resistivity would mean that it's closer to an insulator, so it's harder for electrons to move through this material. Tripling the length would make it harder for electrons to move too. The cross-sectional area hasn't changed, so now this is 2 times 3 of the original value, or 6 times larger than the original. But since the original was 10 ohms, I actually know this number. The new resistance is 6 times larger than the original 10 ohms, so the new resistance is 60 ohms. All right, so I should be able to use this equation to get proportions, be able to tell if this value is smaller or larger than the original, and by how much. If I know the original resistance, I should also be able to use this equation to find the actual value of resistance. Now, let's take it a step up. This area is the area of a circle. So I need an additional equation. The area of the circle is pi radius squared. So we're going to keep these two equations in the back of our mind, because now let's say I do proportions, but I don't tell you how the area changes. I tell you how the radius changes. Putting these two together, I can combine both equations. By substituting A into A, my new equation says that the resistance of a wire depends on the material it's made of, that's rho, L, that's its length, over pi r squared, assuming we know the radius of the wire. Now let's do an example with this one. If I wanted to do proportions then, and I know that I have twice the radius, notice that my new wire would have actually 4 times the area, because doubling the radius would actually be 2 squared, or 1/4 of the original equation. Now notice what I'm doing here. When I sort, I'm doing 2 squared, because that's distributive property. It's actually 2 squared r squared. That leaves a 4 in the denominator and no changes in the numerator. So sorting this out, this reads 1/4 of the original resistance. Notice how this that I sorted to the right is the original resistance equation. So changing the radius has that squared relationship in the denominator. All right, so if your class only needs to know proportions, you're set. But if your class has to solve problems, stick with me for a second. Now let's say I want to solve this problem. And in my new example, I give us something that we've measured. Let's say that I want to find the resistance of a wire that I know. The resistivity of silver is 1.59 times 10 to the negative 8th ohm meters. Let's give the silver wire a length of 100 meters. And let's give it a radius of 5 millimeters. Before I substitute and solve here, I need to change millimeters to meters. Fun fact, you need to do this first. When you convert, you need to do that as your very first step before you plug it into the equation. Otherwise, you'd have to convert at the end, but twice because it's r squared. So let's not. Let's just do it once. Looking this up on my chart, 5 millimeters is 5 times 10 to the negative 3 meters. So I'm replacing the m for milli with 10 to the negative 3. But from here on out, I can just substitute and solve. So the new resistance, or the resistance of this wire, would be rho L over pi r squared. So that's 1.59 times 10 to the negative 8th. L is 100. And that means in the denominator, that's pi times 5 times 10 to the negative 3rd squared. Now, I'm going to show you how to do this in Desmos. One thing I like about calculating in Desmos is because it always makes it very clear that your powers are correct and that your order of operations is correct. Notice that for this, I can be sure that this is reading pi times the radius. That's 5 times 10 to the negative 3 meters. In case you have trouble finding how to get this power of 10, I'm pressing the caret button, the one that goes up, or Shift 6 on my computer. There we go. All in all, this silver wire has a resistance of 0.02 ohms. Now let's check to see if I've got all the right steps. I listed my knowns and unknowns. I wrote out my original equation, or at least something close to it. Right? I may have combined pi r squared to put area in the denominator, but I wrote out an equation that shows that I know which physics equation makes sense here. I didn't just pick a random equation with an r in it and put numbers in. I'm showing clear substitution, so that's my resistivity, the length, and the radius. And I've got my powers of 10. As a last problem, let's do something tricky. This is the hardest one you would have to do. Or at least the hardest one you'd have to do for the homework. Let's say I'm in class and I get a reading with a length of 10 centimeters. I can figure out the resistance using the multimeter is something like 2 ohms. I know the resistivity of the nichrome wire we used in class was 150 times 10 to the negative 8th ohm meters, and I am mean. I want you to find both the area and the radius and the diameter. So let us do this. Step 1, I got my knowns and unknowns. My column is filled out. Step 2, let's write down our resistance equation, rho L A. I know R, the resistance is 2. I know rho is 150 times 10 to the negative 8th. I know L is 10 centimeters, so I'm going to replace the centi with times 10 to the negative 2. So this means 10 times 10 to the negative 2 meters. And just for funsies, I'm going to substitute that right in here. So that's 0.1. I evaluated that in my head, but feel free to leave it as 10 times 10 to the negative 2 if you want to do that. Over A. Now, sometimes people have trouble solving for something that's in the denominator. So in your head, I want you to think of what would be your first step in evaluating this equation. Because you know what mine would be is I want A by itself in the numerator. So what I'm going to do is multiply by A on both sides. Because these A's cancel, I have 2A equals 150 times 10 to the negative 8 times 0.01. Now I still want A by itself. So what I'm going to do is divide by 2 on both sides. See how the 2 on the left cancels? This leaves A equals, I evaluated this in my calculator, and it's 1.5 times 10 to the negative 7th over 2. So this is 7.5 times 10 to the negative 8th. Cool, so I found the area. How do I change from area to radius? Well, now I'm going to pull out the area equation. I used up my resistance equation, so I can't use that. Area of a circle is pi r squared. So if I know A, I can find r. Let's do that. If we know the area is pi r squared, and the area is also 7.5 times 10 to the negative 8th meters squared, I would divide by pi on both sides. This leaves r squared by itself, so I need a square root to get rid of that. Substituting into my calculator, this gives a radius of 0.00015 meters. Finally, how do I turn radius into diameter? Well, silly, radius is half of the diameter of a circle. So multiplying this by 2, the diameter of this wire is 0.0003 meters. Or if you want to convert it into units that make sense, this is 0.3 millimeters. Very, very, very small wire, but that makes sense for what we did in class. So let us recap. If your class only needs to know proportions with this equation, then focus on the problems we solved on this page. We used the resistance is equal to rho L over A to find the proportions. And maybe we could use that to figure out the actual value of resistance. But if you actually had to solve this equation, you'd be expected to calculate using substitution along with metric powers of 10 and this area equation of a circle. The most difficult thing we could do is all of those and finding radius and diameter. Best of luck.